Okay, this is Unit 2 rational numbers. So we're going to be doing the difference between rational numbers in terms of all of our BEDMAS operations. Okay? So we're going to be taking separate things here. Now, what we're going to look at here, this is called a Venn diagram. Now, a Venn diagram is just basically a picture of a way to organize things or categorize things. So if you take a look here, we've got the real number system. So every one of these categories is in the real number system. But does anybody see a circle that's confusing? I think they forgot one of them. Whole numbers, good. So whole numbers is missing, and it should be circling around the natural numbers. So that should be whole numbers. Now, it's not very much bigger. So what number did they put in there? There's only one other number. 0, good. So whole numbers, they add number 0 to the natural numbers. Okay? What's that? Yes, 0 is in the integers because it has to be. Because if we take a look at we remember our boxes, right? So we have to take a look and see which number system would fit into the others. So our smallest number system is our smallest box, which is natural. Then we've got the whole numbers. And the whole number box, all it does is add a 0. So we've got these numbers are inside there. But can I fit a 0 inside the natural numbers? No. It's too big. There's not enough numbers in this one. Okay, this guy's too big to fit in there. Then if I compare the integers, our counting numbers, you bet they're in the integers. But whole numbers, are they in the integers? Yes, that's why they include the 0 right here. But can I do it backwards and say, oh, well then every integer is now a whole number? Would all those numbers fit in that box? No. What side of the number line do they open up? What extra types of numbers do I have in the integer box? Good, I've got all the negative numbers. So remember when we talk about the real number system, we're basically talking about a number line. So we're talking about a number line and which parts of our number line are opened up. So when we talk about natural numbers only start right here in the positives. They start with +1 and they go right to the end. Then we open it up. We keep opening up numbers by going to the left. So we open up the next one, which is 0. That's the whole numbers. They open up 0 on the number line. Then the integers show up and they open up the left side of the number line. All the negative numbers and positive numbers. But then we go into the rational numbers. What kinds of numbers are in there that do not fit in those other 3 boxes? There's only 2 kinds of numbers in there that don't fit. One starts with an F. Fractions and decimals. Good. And there's 2 kinds of decimals. We have the repeating ones and we've got the terminating ones. Okay? All of the run-on decimals, these guys here, those are the run-on decimals that never end. Okay? So what's this little symbol down here? That's pi. He's an irrational number. We also know of another number. Euler, letter E. That's another irrational number. Okay? So, irrational numbers are the ones that run on forever. Those are the non-perfect square roots. So, let's take a look at this investigation question. So, when we talk about answering different questions, a lot of them are based on BEDMAS skills. Like we talked about with skill testing questions for radio stations or whatever. They're usually all BEDMAS stuff. Do you know how to use the proper order of operations? That's what it's talking about. So here we've got a small technology company is beginning to expand. The company currently has 100 employees. At the end of each year, for the next 3 years, 20 employees retire. And a new employee will be hired for half the remaining old employees. Then it says, after this 3-year cycle of retiring and hiring is complete, how many employees does the company have? So, we're going to take a moment to think about that one. So, the question tells us that we start with 100 and 20 will retire. So here's year 1 minus 20 people. So if I minus my 20 that retire, I have 80 people. But then it says they're going to hire half that many that year. So So they're going to not hire half of the amount that retired, they're hiring half the amount that are still working there. So they're going to add half of 80. Half of 80 is 40. So at the end of year one, you should have 120 employees. So then year two starts with 120. Subtract the 20, gives you 100. And what's half of 100? 50. So now you're going to add 50 to that. That's going to give you 150 at the end of that year. So year 2 ends with 150, year 3 starts with 150. We subtract 20 employees, that leaves us 130 people left working. But now I have to hire half that amount of people. So how many is half of 130? Because we're going half of that is this. Half of 80 is 40. I want half of 130, which is 65. So now if I add 65 to my total, I'm going to get 195 employees at the end of the 3 years. Okay? So, some of it's a little bit of guess and checking, and some of it is finding a process. Okay? Alright. Let's take a look at the next one. I'll let you write that down. Some of you are still writing. Okay. So one of the things that you're going to notice is every lesson has an outcome that we are working on, and they're numbered according to the Alberta government. So the one we're working on right now is called Outcome N3. And what we're doing is we can order and categorize rational numbers. So we want to be able to compare them and order them. So the ones we're worried about are definitely all of our fractions and rational numbers. This unit is dealing with fractions and decimals. So we talk about fractions over here. So it says fractions are in the form A over B. You're always going to see this form A over B, okay? So whenever you see this, they're always talking about a fraction. But they're always going to tell us that B can't equal 0. And what that means is you can't divide by 0. If you take your calculator right now and you try to divide by 0, it's going to say error or syntax error. You can't do it. It's impossible to divide by nothing. Okay? You have to have something to divide by. So that's why it's an error or syntax error. Okay? So, when we talk about decimal form, any kind of number can always be put into a terminating decimal. I can change any digit to a decimal by going 0.0. Okay? So every number can be put into a decimal if it is a rational number. If it's an irrational number, those are one of the things that are different about them. Irrational numbers can never be put into fractions. And the reason they can't be put into fractions is because they're run-on decimals. They keep going forever. And if they don't stop, if they don't have an end, we can't put them into a fraction. But repeating numbers can be. So repeating numbers always have a 9 on the bottom. So this guy repeating would have been actually 3 over 9, but actually got reduced to 1 over 3. So repeating numbers are always over the digit 9. So if you've got a number, let's just take an example here. If I've got the number 5 over 9, and I want to convert that to a decimal. If the bottom number is a 9 of any kind, then all you're doing is you're going to take the top number, and that's the number that's being repeated. So this guy's going to be 0.5 repeated, and you can check on your calculator. If I go 4 over 9, what's going to repeat? The 4, 0.44444. What if I go 1 over 9? 0.11111. Good. What about 7 over 9? 0.7777 forever. Okay? So that's how we deal with those guys. Now remember, these repeating, or terminating decimals, they are still rational numbers. Okay? Because we can put them into fractions. Now, again, we're talking about number lines. Now, what are the characteristics of number lines that we actually do know? Well, every number has a spot on your number line. Absolutely every number, even those non-perfect square roots, those run-on decimals, they do have a spot on the number line. So, when we're taking our rational numbers, we know all rational numbers can be put into decimal form. So the first one is if you convert them all to decimal form, we can compare them according to their location. two blanks there are decimal and location. So that's what we do. If I've got the number 5.6 and I've got the number, let's go with 5 6/9. Well, 5 6/9 is a mixed number. That's going to give me what kind of a decimal. Take a look at the fraction. What kind of decimal should I get there?
6.
Right, 5.6 repeating. Good. Now, if I were to compare these are both positive numbers. Which one goes first on the number line? Which one would be first on the number line? Closer to the 5. Who would be sitting first? I'll name them A and B. Who goes first? A or B? A goes first, yeah. So A is closer. Just think of how many numbers are after this one. I have lots and lots of 6s at the end of this guy. Whereas the first one over here, it terminates, it ends, it's only got 1 6. So the minute you start adding extra numbers, it's a bigger number and it's moving further away from 0. Okay? And that's how we deal with big, big decimal numbers. Okay. So let's take a look now. On your sheet, you've got example 1 here. Now, all those numbers are not in the same format. Some are in decimal form, some are in fraction form. So what we have to do is convert them all to decimal form. So we're going to take -1/4, and it's going to become -0.25. We're going to take 2.5, and that's going to become 2.5. Okay? And again, what have they done? They have located them on the number line. Right here, we've got 0 on the number line. Okay? 0.3 repeating is closer to 0. Okay, that's why it's super close in there. So what I'd like you guys to do is, using this example of where they're putting all the numbers on the number line, I want you to label all of these ones. So you've got letters A all the way to I. I want you to label them and put them on the number line where you think they go. Okay, so you first have to convert them all to decimals and find out where they go on here. Okay? Give me a couple minutes to do that. Push pause now and play when you're ready. Okay, so you got a couple minutes. Let's take a look at where these belong. So you should have way over here letter A. Then who goes next? A, G. Letter G is in here somewhere. Then we've got C is closer to 0. Not quite that close. It's over there a little bit more. Then who do we have?
D.
D is in here.
And B.
Sorry?
And B.
B boy, yup. Okay, what else?
I.
He's about in there. Okay.
F.
F. Yep. You bet. H is right there. E, letter French, letter Okay, do you have all the letters up there?
Yeah.
Did everybody agree with what we got done?
Yes.
Absolutely. Now, which ones give you a bit of trouble? Sometimes it's the fractions. So when we do fractions, you have to take the top, divide by bottom. Wait, so it's a negative fraction? Yes. Yeah. Okay. Now remember, we also have to count the number of negative signs we have. If you've got multiple negative signs, 2 or 4 or 6 would make it positive. Odd numbers would make it negative. All right, let's take a look now at inequality signs. Now, inequality signs basically tell us whether something is going to be bigger than or something is going to be smaller than. So we have greater than, we have less than. So, on any number line, the smaller numbers are to the left, and as far as you keep going, the numbers keep getting smaller. Even though the digit itself looks like the digit's getting bigger. It just has a negative sign in front of it. So watch how this works. So if I put the number negative 3.222 repeated, well, that guy's going to be over here. Okay, right there. And if I put the number 3.222 positive, He's going to be about right there. Now, the one thing you want to know is they are equal distance from the center. Okay, they're equal distance from the center. A positive and a negative of a number, they're equal distance from the center. Now, if I want to make a number even smaller than that, I need to add another decimal to the end, and it's going to be further to the left. If I wanted to change the number, so I got 2, 2, and now I'm going to put a 3 at the end. That digit itself, without the negative sign, looks like it's getting bigger than that other number I had there. Well, it really is bigger, but with the negative sign, it says it's actually smaller. But what it means is it's getting further away from 0, okay? So the numbers are walking away from 0 if you think about it that way, okay? So we're going to talk about inequality signs and who's going to be bigger than or smaller than another number. So if I've got 3 and 7, the way we do this, if you're used to the alligator mouth or whatever, the alligator mouth is going to eat the big one. It points to the small one. So I would say 3 is less than 7. Now, you could also do it like this. Everybody take your hands and put them up like this. Make L's with your hands. Okay? Now, put your right hand away. This guy, that's your less than sign. Your left hand, think left is less than. Okay? So whenever it points this way, it's always less than. Okay? No matter what. Think of your left hand. Okay. So now, what about negative 6 and 3? Which sign would go there? How would you read that?
But isn't it like little number gets the big number?
Pardon me?
Isn't it just like little number gets the big number? Is that easier?
Whatever it takes for you to remember it, sure. That's right. So it's going to be less than again. Okay? So negative 6 is less than 3. All you're doing, if you take a look at it, is look at where it is on the number line. Think of the sign as being an arrow to where it's pointing on the number line. So we're going to be doing lots of number line work in the next 2 or 3 units. So we have to pay attention to the way this works. Think of this guy, watch up here everybody please. Think of that as an arrow pointing to the left. So that means this guy is less than this guy because he's further on the left. That's what's actually going on. Okay? Now, what about 5 and negative 8? What's going on with that one? Good. 5 is greater than. Now, how do we know? Because 5 is on this side of 0. Try to think of which side of 0 they're on and point that direction. So 5 is to the right side of 0. Now we have 2 negative numbers. This is where it gets tricky. It's dealing with our negative numbers. Now remember, if we're dealing with numbers that are getting away from 0, negatives, the numbers get bigger as they go away from 0. The minute you put the negative sign on it, it means smaller negative number. But remember what you're doing is you're counting the number of steps away from 0 it actually is. So we've got a negative 3 and a negative 5. Is negative 3 bigger or is he smaller? He's bigger because he's over here. Negative 5 is over on the left. So since negative 3 is further on the right, I'm going to put this sign because he's pointing to the right. Okay, so that's why I'm saying greater than. Okay, so does that make sense on how those signs point? That might help? Okay, so let's take a look at the next few. So, 2 over 7 and 3 over 8. Oh my goodness. They're not integers anymore. Uh-oh. Now they're fractions and decimals. So now what do? You put them into decimals. Good. So 2 over 7. How big of a decimal do we have? 2 over 7. 0. Pardon? 0.28. Thank you. Sorry, I just couldn't hear. Okay, what about 3 over 8? 0.27. Oh. Oh, 3.7? Okay, thank you. All right. On the number line, which number is bigger or smaller? Is 0.28 smaller or bigger? Smaller. So which way should I point it? Is it closer? Pointing that way. Okay, it's less than. You're always talking, whenever we read a book, you guys, whenever you read a graph, whenever we read inequality statements or any math statements, you read them from the left to the right. So we're saying that this number is less than this number. Okay? But, yes, that's what we're saying. This guy less than this guy. Okay? You have to think on the number line of where they're at. Okay? What about this one? We have a negative number and a positive number. Do I even have to change them into decimals? No. If one's negative and one's positive? No. We should instantly be able to tell on the number line where they go. So, who's bigger, the negative or the positive? The positive's bigger. So, we're starting with the negative guy. They have to say he is less than the big number. Okay, so you're pointing to the left. Alright, on letter C, again, we have the same situation. We have decimals and fractions, but we don't have to convert them because one's positive, one's negative. And positive and negative should be obvious where they belong. So, who's bigger? 22/7, the positive one. So we're going to say he's further to the right, right? So we point him to the right. He's further to the right than this guy. Okay? We're trying to see on the number line where he is. Is he further to the right or further to the left? He's greater than, further to the right. Alright, let's take a look at this one. Uh-oh, now they're in decimals again. So we just did this decimal over here. So we have negative 0.28. Alright, now we have to see, the difference is, on the left-hand side, these guys are positives. Now they're both negatives. What it's going to do is it's going to swap the idea around, okay? So, with negative numbers, a smaller digit is bigger. So that means that the 2/7 is bigger than this guy, okay? He's greater than. Now, how come? Because he's closer to 0, okay? He's closer to 0. If I were to put both those numbers on the number line, one of them would be right about there, and the other one would be right about there. Whichever one's closer to 0 is the bigger one. Okay? Whenever you compare negative numbers, and we're going to write this statement down, strategies comparing fractions. Okay, so first one, change to decimal form. Okay, so that's the first thing we'll write down. Change them to decimal form. Now, strategies for comparing negative numbers is what we also need to write down. So, we've got our strategy for comparing fractions, and now we're going to do strategy for comparing negative numbers. So, first thing we need to do when we compare negative numbers is find out where they're located on the number line. Okay? So the general rule is whichever number is closest to 0 is the bigger number. Okay, so that's super important. When you compare negative numbers, whichever number is closest to 0 is the bigger number. Okay? Bigger in terms of on the number line, who is larger. Okay? And if you were doing it in terms of weight on a weigh scale, okay, the further negative numbers would weigh less, the positive numbers might weigh more. I'm not sure, you can do it opposite as well. Okay, but whichever number is closer to 0, he's the bigger number. And we'll do an example of that. Another one. Another one. Okay, I'll give you a moment to write that down. Okay, let's throw our other example up here. So one last example. Example. negative 4.678. We want to know if it's bigger or smaller than negative 4.679. Oh boy. When you take a look at those numbers, the only different number is the guy at the end. So, we need to know if we're putting them on a number line. Let's visualize our number line. There's 0. Here's our negative 4. Here's our negative 5. One of them's going to be right here, and one of them's going to be right beside it. They're right beside each other. So I'm going to label them. We'll call this guy A. We'll call this guy B. In my very first spot, right here, closest to negative 4, it would go there. Who's going to be closer, A or B? It is A. Yeah. So A is there. And then we would put B right here. So the minute we add numbers to the end of it, okay, if you're adding decimal numbers, you're adding extra points to it. So what that means is you're making it, if it's a negative, you're making it further away from 0. It's walking away from 0 the more numbers you add. Okay? The less numbers there are, walking closer to 0. So this guy is greater than that guy. How come? He's closer to 0. Okay? He is on this side closer to 0. Okay? That's how that works. Let's take a look at our couple other examples here. Now, how do we find a decimal or a fraction between two numbers they tell us? Well, strategy, first thing we got to do is change them all to decimals. Okay, so change all to decimals. Okay, so that's the first thing we got to do. We got to change them all to decimals. Now, you guys have the answers. You've got the solutions for all of them. So I'm just going to walk through and see what they've done. So, what have they done? Well, they didn't change them to decimals. Well, they did down here. So one strategy, you're going to get 0.81. There's a decimal, and 0.7 repeated. Who would be the bigger number? Who's bigger, a 0.8 or a 0.7? If you were thinking of, in terms of dollars and cents, 0.7 would be like 70 cents. 0.8 is like 80 cents. It's in terms of money. Which one would be bigger? The one with the bigger money. So that means 0.81 is bigger. Okay? So, how could we also figure this out? We could also figure it out by doing a common denominator. And that's what these are. These are what's called common denominators. So what have they done? They've multiplied the bottom numbers. So what they've done is, this number right here, they multiply the top and the bottom. Then they take the number on the bottom left and multiply it to the top right and the bottom right. So they're combining them to make common denominators. And then what you do is you've got a range between the numbers, and you can see where they are. If they're all converted to the same denominator, you can put them in a row and see who's bigger and who's smaller. If they all have the same bottom number, go by the top numbers. Who is ever bigger on top is the bigger number. If they're negatives, the smaller on top is closer to 0, which is bigger. Okay? So, in this one, we get a range. This guy here becomes 81 over 99. Then we have 77 over 89. So comparing the decimals, we already know who's bigger. But if we want to find out a number that can fit in between them, this is when we have to use these strategies. Okay? So what they're showing us here is any numbers that have a top number between those numbers. So we could have 78, 79, 80, okay? Any numbers in between 77 and 81. That's what it's showing us, okay? Those would give us answers in between those two decimal numbers. So whenever they're asking about that, always find a common denominator, Okay? So B does the exact same thing. Whoops, I got my pen down here. Let's erase this stuff. And I'll show you B now. So, put A away, and B can come out. Let's see. Come on, B. Alright, they did the exact same thing to the bottom on B. So, the bottoms, they multiplied the bottoms. So if I multiply 23 over here, I have to do it to the bottom and the top. If I multiply 25 over here, I have to do it to the bottom and the top. And that's what they're showing you they did. So, then they get two new fractions. Once you get your two new fractions, you get numbers that are going to be within a range. So we get the numbers right here. So we want numbers between negative 525 and negative 529. So what numbers fit in between there? Well, 526, 527, and 528. They all fit in between those two top numbers. So the minute we found the common denominator on the bottom, it's easier to find out what numbers can go in between. Okay? When they're in decimal form, it's easy for us to find a decimal number that goes in between them. But if they want a fraction, we have to use this strategy. Okay? So the same thing's going to happen if we take a look at C. They've done the exact same thing with C. They've changed their bottom numbers. So we have 256 and 255. Okay? So what could be a possible number? Well, add a 0.5 in there. Okay? So they've added a little 0.5 there. Okay? Any questions so far on how to create these common denominators? We will see it come up again, don't worry. No? Yeah, once we get working with it, it'll be a lot better. Okay. We are going to compare those. So these are for you to practice. Pause now, when you're ready. You've got a couple minutes to figure this out. So you should have greater than and greater than, less than and less than. Let's check your work, please. Make sure you did it correctly. Then you also have a couple moments on the clock talk. So let's take a look at the clock talk question and see how you did on it. Okay, so the clock talk goes like this. If it's 7/8 of an hour, well, hour is 60 minutes. That's going to give you 52.5 minutes. Now, we're going to take the 0.5 minutes, and we're going to times that by 60 seconds per minute. And that's going to give us the number of seconds. And that's going to equal, of course, 60 seconds. And it is 30 seconds. So, our clock talk total time is 4 o'clock, 52 minutes, and 30 seconds. So 4 minutes, 4 o'clock, 52 minutes, and 30 seconds after time. Okay, your workbook pages to do. This is the end of lesson 2.